Good morning, everyone, or afternoon or evening. Thank you for joining today's webinar. My name is Greg Keating. So to save on bandwidth, I'm going to turn my camera off, and I'm going to share my screen. And hopefully everyone can see my screen now. For those of you who are not running on version 10 or using CloudSuite Industrial at all, this is what we refer to as a home page. It's a landing page. It's the page that we're going to refer to during today's presentation. We're going to navigate through and use this to access various areas of the application. So first I want to start out with an overview of the manufacturing system, just so everyone's aware of the different types of manufacturing capabilities that are supported within CloudSuite Industrial. So CloudSuite Industrial works best in what we refer to as a hybrid environment, meaning you don't have to have a one-size-fits-all manufacturing method. I'm going to walk through a couple of these here, but think of each one of these boxes as means to which you can consume capacity or run your manufacturing facility. Job orders. That one's pretty straightforward, a discrete job. You get a quantity or get an order to produce X number of widgets, you produce those widgets, that job is done. Then you also have the box in the middle here, referred to as a production schedule item. And a production schedule is for repetitive manufacturing. You're making the same type of products or similar products day in, day out, and rather than creating discrete jobs, you can create kind of like a blanket job that you're just adding releases to. You know, today I'm going to make 100, tomorrow I'm going to make 150, then 125, and so on. And it's a lot easier on the planner and the scheduler because you're not creating jobs for the same items, 3 or 4 times a week. We also support what we refer to as a JIT or a Kanban. This is a work orderless environment, meaning that it's very easy on the operator. It's a work orderless scheme. Now, with the work orderless scheme, you give away certain abilities like actual costing. Everything would be at standard cost in a JIT and Kanban environment. Very easy on the planner. There is really hardly any planning to do. Now, also unique with CloudSuite Industrial is service orders. Service orders can consume your capacity. So service orders could be not only the repair of the products you provide, but also the repair and maintenance of your equipment, your machines in your facility. So let's pretend for a second that you manufacture forklifts, and you have a fleet of service people that go out to the field to repair or do preventive maintenance on the forklifts that you sell. But then you have a different group of people that are maintaining your welders and your press brakes and your CNCs in your facility. Those two can be processed on service orders, both of which are consuming capacity and feeding the master schedule. Lastly, projects. Maybe your organization is project-based. You're building a display booth for a trade show, or you're bringing a new product to market, and you need the R&D and the development and the testing and everything else to consume capacity of your operators and machines on your shop floor. And that too can drive into your master production schedule and your capacity of your facility. So all of these, it's not one size fits all. All of these can be operating in the same manufacturing environment. So you can have a blend between maybe certain things are produced on jobs versus certain things on production schedules, and other things maybe that, let's go back to that forklift example. Each forklift is somewhat configured, so that's produced on a job because it's, that one forklift is being built to this specific specification, but maybe the tires are always the same, so you're building the wheels and the tires on a production schedule, and you're using repetitive manufacturing, and then you ship that forklift in a crate. Well, the crate, you just need to know that the crate's been built, so maybe that's running on a JIT or a Kanban. And all three of those examples there can run and consume the same resources and the same capacity in your production schedule. Hey, I'm going to cover for a brief moment here some of the finer points of APS versus MRP. So APS is advanced planning and scheduling versus MRP, material requirements planning. Most folks are familiar with what an MRP system is. But there are some distinct differences between APS and MRP. The first one is, well, let's look at lead time. So APS is going to consider the item's routing and resource capacity and determine a process lead time. Okay, it's going to actually look at the demand, at the load in that given machine, or the load on that pool of operators, and it's going to determine when it's available, and that becomes its lead time. MRP, you establish a static lead time. So MRP is not aware of what else might be going on in the facility. It just says it takes you 10 days to make this part, therefore it's always 10 days. The bills of material. Now, the APS will plan requirements for the entire bill of material from the top level down. Versus MRP will do it by what's referred to as a low-level code, which means it plans the lowest low-level code. The top level is level 0, and then as you're going down the bill of materials trees, you have level 1, level 2, level 3, components of components of components, and so forth. MRP starts at the bottom and just goes bottom up across all the different items, versus APS is going to do them top level at a time. And evaluate the capacity and the constraints for each one of those individual components. A backward and forward planning. This is a unique one for APS versus MRP. APS will attempt to backward schedule. So in other words, you give it the due date of the demand, and it will go backwards in time and tell you when you need to start. And if you encounter today's date, APS will automatically flip it to forward scheduling and say, if you started today, when will you have it? MRP, on the other hand, only does backward scheduling. So you'll get requirements or you'll get demands in there that say you should have started this 2 weeks ago in order to be on time. That information really doesn't help you in planning out, a commitment date or a projected shipment date to a customer. I'm assuming none of you guys make time machines. So it doesn't do you any good for the system to tell you should have started something 2 weeks ago. Lastly, capacity. So APS is considering your resource capacity when it's planning material deliveries and commitment dates. MRP does not. MRP assumes infinite capacity. If you can make 100,000 widgets a day and you get an order for 2 million of them, MRP says, bring that material in. You can do it. Versus APS is going to say you can't make those 2 million widgets by tomorrow, but you can get them in 3 weeks, let's say, because the machine only produces parts so many per day. MRP doesn't has no concept of resource capacity. So let's talk about resources for a moment and what a resource is. I'm going to be flipping back and forth between full screen and partial screen here, but let's look at what a resource is. So I come from a stamping background, worked in metal stamping for over 20 years. These are the resources needed to make a stamped part. Now, your industry is probably very similar. Most manufacturing industries are almost universal in this respect. We're making the part in the middle there, the metal donut. In order to stamp that part, I have to have 4 things. Okay, I have to have a press that's going to stamp the part. I need a part-specific die that's going to cut the part into that shape. I need an operator to staff the press. And lastly, I need raw material to feed through there and convert into that part. So if any one of these 4 items are missing, I can't manufacture the part. I'm stuck. It's a 4-legged stool. If I take out one of the legs of the stool falls over. What APS is going to do is align the availability and capacity of each one of these 4 items or 4 inputs. And when they are all available, it will say, now you can execute and manufacture the product. Now let's talk about a job versus APS. And I'm using the term job here, but let's just say the firm schedule versus the soft schedule. APS works best when we're operating in a soft environment, or let's say a soft schedule. Meaning that in the soft schedule, the demand is fluid. I mean, I've never heard of any customer that gets an order, or any company that gets an order from their customer and it never changes. No orders ever change. So the soft schedule, the APS world, demand is fluid. Requirements are coming in, they're coming out, dates are changing, quantities are changing. All that is changing and moving around. That's what we refer to as the soft schedule. That's the APS world. Okay, and the APS world will realign resources, reevaluate capacities, reevaluate inventory positions, and so forth, and make recommendations on executing a plan. Now, once we get to a certain period of time, in this example, it says 3 days. I can't tell you what the right window is for your firm's schedule. That is, dictated by your organization. I can tell you, my former company, we were 48 hours. So the jobs we were creating today were starting in 48 hours, and that was our firm production schedule. So once we transitioned from the green box into the blue box into the firm schedule, is when we're really firming up or locking down our plan. So that 48 hours, and I'll use metal stamping examples here, allows you to mount the die, to get everything, to get the die pre-staged and any components pre-staged and so forth. So when it comes time to set it up, everything is there and ready. Now, you can be successful at that when you have a relatively stable production schedule. And how you attain that stability is by not creating your jobs and firming up your schedule out 3 or 4 or 5 weeks in advance, because it's probably going to change 10 times in those 5 weeks. So keeping that firm window as small as possible is actually to your advantage. It saves your production scheduler and planner work from having to redo things, or redo job packets and pull paperwork back and so forth. It actually makes it a little bit easier on them. And the system operates just fine with the soft schedule. Purchasing is seeing material requirements. Maintenance is seeing what the demand and what the plan is for the work centers out. As far as you have demand in there, as far as you have customer orders in there, it's visible to the entire organization. You do not need to create a job or a production schedule in order to firm up or show material requirements. The system will work just fine in the soft schedule world. In light of our audience, about half of our audience are not currently using CloudSuite Industrial. I do want to go through one quick PowerPoint that explains some of the algorithms in a little bit more detail than what I showed today. And then we'll spend the balance of our time going through how to fine-tune, for those folks that are using it today, how to fine-tune it and get the most out of it. And I'll show you some examples. But I want to come back to this presentation here. Now, this slide you've already seen. I've already walked you through this. But I want to talk about resource groups and allocation sequencing. It's a fancy way of saying tiebreakers. How does the system determine what we should run next? And this box on the right over here, think of these as tiebreakers. So in this example, I have 4 presses, I have 3 people. I'm constrained. I have a labor constraint. I can't run all 4 presses at one time. So how do I decide what should run and what gets precedent? So I'm going to look first at the APS order priority settings, which I'm going to show you this form in a moment. It's a global way to give different priority settings to different types of demand. For instance, satisfy customer orders before you replenish safety stock. Then we'll look at the due date for the demand. Now, these are tiebreakers. We'll look at the due date for the demand. So whatever's due sooner is going to run sooner. If that's a tie, then we'll look at the create date for the demand, and we'll FIFO out our demand. Whatever order you've had on the books for longer, we're going to want to satisfy. For instance, you've had an order for a month that's due on Friday, and you get an order today that's due on Friday. It's going to want to satisfy the older order first. Then we'll look at the order number and the item number. What's our resource structure? In this simple example here, I have part number 1, 2, 3. Part number 1, 2, 3 runs in the CNC Work Center. The CNC Work Center requires 2 types of resources. It requires an operator, so I have a pool of labor, and it needs a machine, so I have a pool of machine. The resource group is my pools. Now, my individual resources down at the bottom, I have 2 operators and 2 machines in those particular groups. Now, what happens if I have a unique part number that can only run in one machine. Well, I still have my part number 123 example from before, but now I introduce part number 456. And part number 456 can only run in machine number 2. Something's different about machine number 2 that only part number 456 can fit in there. So I don't create another resource because I still only have one machine. So I create a second resource group or a second pool that I route part number 456 that has to run through the unique machine group. However, part number 123 can run through either machine, so it doesn't matter. And this is how you set it up. Now, in the end, when we're doing our finite planning and capacity planning and so forth, we're doing it at this bottom level, at the individual resource level. Now, we talked about the backwards and forward scheduling already, so I'm not gonna spend a lot of time on this. Blocks of time. The system wants to plan and schedule in contiguous blocks of time. So if you get a demand out there that says you need X number of hours to produce it, the system is not going to tell you to break that up into 3 or 4 different setups, do 25 of them here and 25 here and 30 here and so forth. It's going to want to set it up once and run it in one contiguous block. Now, there are ways that you can control how big that block of time can get, and I'll show you that in a moment, but the system is not going to automatically break it up for you. Now, in this example here, I have this demand, this new 1, 2, 3, 4, and it's going to look for a contiguous block of time big enough to fit that, and the first one it finds is in resource number 3 on day 4. Let's get into the application. So I'm going to start with the APS setups. And the first thing I'm going to start is with the APS order priority form. And I'll go ahead and open up this form. Here are the different types of demand. Now, this is a global setting that I'm giving different priority to different types of demand. The lower the number, the sooner that demand would be satisfied. When you think of running a full APS planning cycle, think of it this way, as one gigantic whiteboard. And every time you run a planning cycle, you're going to go and erase that entire whiteboard, and you're going to take all of your orders and safety stock replenishments and everything else and refill them. Well, this form is controlling what you're going to put on the whiteboard first. So the lower the number, the sooner it hits the whiteboard. So in my example here, I'm saying all my orders coming in via EDI are my first priority, and then the ones entered manually, then coming in through my web portal. And then I'm going to do transfer orders. I'm going to do things for my sister facilities. And then down here, I'm replenishing safety stocks and building forecasts. So as that whiteboard is filling up, if it gets full, what am I pushing out? My forecasts, essentially. Well, actually, my MPS ones are at the bottom of the list, but you can see as the whiteboard's filling up. Now, I can control this. So if let's say safety stocks are really important to me, I can come here and give this a number. I'm going to say it's 1,400. I'm going to hit the save button, and I'm going to hit the refresh just so I can get it to resort for me. And now I just told it satisfy safety stocks before all these other things. But I can also take that a step further, and I can come in here, and I'm going to put a 900 in, and I'm going to say, I have that 800-pound gorilla customer. And in this case, let's say it is, I'll pick somebody at random from the list here, Big Creek Quarry. So Big Creek Quarry is my 800-pound gorilla customer. And now I've just told the system, take care of Big Creek Quarry first. Then take care of my EDI and my order entries and safety stocks and so on and so on. But I can take that even one step further. And I can put in, let's say, a priority 800. And some customer was just kind enough to call and say he needs his orders right away, and I will give you a substantial break-in fee if you can do it. And we say, yes, sir, Mr. Customer, we can do that. And so now I put in whatever order, DC 350 on that order. So now I just told the system, take care of this order, DC 350 first. It's the first thing that goes on the whiteboard. And then I'll take all of Big Creek Quarry's orders and put them on the whiteboard. And then I'll go down there and satisfy the rest of my demands. So again, this is your number one tiebreaker for establishing priorities on allocating out your capacities. Now, let's talk about resources for a moment. And here's where we're defining our resources. I'm just going to leave the filter wide open here. And let's come down to the 60-ton machine here. So here's a 60-ton Minster press. And I want to talk briefly on how to tune the resources. This is where we define them. Now, this is a finite resource, so I do not have the infinite scheduling or infinite planning. And when we say scheduling, that's the firm schedule, the firm window, the blue box in that previous slide, versus the infinite planning. This is going to be the green box in that previous slide. And so both of these are set up for finite planning. Now I have a sequencing rule and a selection rule, and when this is set to the global sequencing rule, this is your overall allocation method, which basically matches those 5 tiebreakers that I showed you at the beginning. But you can override that at individual resource level by using one of these sequencing rules and selection rules on how you want to sort and prioritize this particular resource. So maybe this one you want to minimize your setup time, or minimize your setup time for the first 10 jobs, and then after that you're going to have to run in a certain order. Or maybe you want to reserve it for a specific job, or you want to do a dynamic sequencing rule, or maybe you want to write your own rules on how you want to set the order. When I think of this as the batting order, how you want to set the batting order in that particular resource. Now, I'm not going to explain each one of these. There's a really good help file for this field in CloudSuite Industrial that explains each one of these and what they mean and how to configure them in the system. Now, also, we are defining our standard work pattern for this particular resource. So this machine is open 2 shifts, starts at 8 a.m., closes at midnight, Monday through Friday. So that's our standard work pattern. But I can have what we refer to as shift exceptions or deviations from this standard 16-hour workday. So here I have a couple of examples in here. Now these are downtime, which means they're minus shift exceptions. I'm taking away capacity. This happens to be preventive maintenance. I put in a preventive maintenance schedule. I'm really bad at completing them on time. But this is a preventive maintenance schedule for this particular machine. And I'm going to take it down for, well, these 2 are 1 hour. I'm really mean to our maintenance department. I make them come in at midnight. But this one's for 1 hour, 2 hours, 2 hours, 2 hours, and so forth. And I'm taking away capacity. That's the example of a negative shift exception for a machine. Now, a negative shift exception for a person, they put in a vacation request form. You put in a shift exception saying that you're going to be down a man for 2 weeks or a week or however long they're on vacation for, and the system will see that, recognize that, and plan around it. And things that maybe were on time may now be late because you're down a man. You can also have what we refer to as a positive shift exception. We're going to add hours. Overtime. You've decided to work this weekend. You put in a shift exception, say I'm going to work 6 hours on Saturday. You put in a shift exception, the system will see it's got an extra 6 hours of capacity, and we'll start pulling orders in to fill up that extra time that you put in. So that's the easy one, is overtime. I want to talk about resource groups for a moment. And I'm just going to leave this wide open. Now, here's where we're defining our pool of resources. So if I come down to this assembly labor here, this was that second row up in our hierarchy. And here I'm defining, I can define at the resource level if that entire resource is going to be infinite. And here I'm defining my pool. So in my assembly labor group, I have 3 individual members that make up that pool. So when I need an assembly labor group resource, it's drawing off of this pool of people. Now, also, I want to talk about how we allocate. How do we determine which resource member gets assigned the work? So we have a couple of them in here. There's a couple that I'm gonna talk about. Select and sequence. Okay, so select and sequence is equivalent to that pyramid of champagne glasses. So you start pouring champagne in the top glass, and when the first glass is filled, it overflows into the next glass, and then overflows into the next glass. So that is what we would refer to as select and sequence. So once resource 1 was full, then it would cascade over to resource number 2, and then resource number 3, and so on. Now, we also have, how do you level load? Well, that is the longest idle. That's this one. So whichever resource has been idle the longest will get the next demand that comes up, the next requirement that comes up. So this is how you level load, or making sure that you're spreading your work across all the resources in that pool. Now we also have, you can do minimum setup time. We also have, you can reserve for a specific job. And lastly, the last one I'll talk about is the cyclic one. And cyclic is you're playing cards and the dealer's just handing out cards. So person 1, person 2, person 3, person 1, person 2, person 3, and so on. And it doesn't matter how long they're going to be running it. They're just assigned out cyclically in that manner. So that is how the demand or the load is assigned out to the individual resources in that resource group, is this allocation rule. And again, you can define that at the individual resource group level. Maybe some of resource groups or departments, if you want to think of it this way, some departments want to be level loaded versus others, you want to wait until one resource is full before you turn on another. Let's say it's an oven or something like that. You want to wait until one oven is full before you fire up a second oven. I do want to talk, and this is going to be directed more for our existing users. I want to talk a little bit about the planning parameters and some of the ones that we can focus on in here. A couple of tips too. The first tip I'll talk in the planning parameters: keep your M day relatively simple or relatively small. Your M day start, M day end. This is when you do a planning cycle. This is the field of view that orders or demands they're going to be considered for planning. So don't put this out like 100 years in the future or something like that, because it's just going to slow down the planning cycle. So, this should be your IT administrators, part of their year-end cleanup thing is to tweak these dates a little bit. Now, I'm not saying make them weeks or months, but don't make them decades. Don't have them extending 15, 20 years because it's just going to slow down your planning cycle, particularly if you're using the Gantt chart. Then also, the plan materials at operation start. If you leave this box unchecked, it will plan all of your raw materials to be available when you start the operation. In some cases, that's fine. But let's say you have 15 operations and it takes you 6 weeks to get through the first 14 of them. Well, why are you going to bring in the material for operation 15 6 weeks before you're actually going to use it? So if this box is checked, it will plan the raw materials for that operation to arrive in conjunction with that operation start date. Now in here, we're going to talk about the day supply down here. This is for consolidation. So do you want to show every order individually on your workbench, or do you want the system to do some consolidation for you? And if you want it to do consolidation, you set these to day supply. Your options here are none, which means no consolidation, or maybe you want to consolidate all the demands that for 1 day's worth into a single line on the workbench, or you want to let you guys decide at an item by item level how you want to do consolidation. And I'm going to show you this in a moment. And on the advanced tab here, this box here, apply order maximum through the bill of materials. So if you have defined an order maximum out there, remember I said there are ways to control how big that block of time, how big we'll allow it to be. Well, that's the order maximum on how we control how many we're going to produce. So do you want to apply that order maximum value throughout the entire value stream, throughout the BOM? And in most cases, yes. If you're running a process that you need to assign an order maximum, if you're doing metal stamping or something where molding, also something where you need to pull the tool and do a preventive maintenance at a pre-described interval, you want to apply that maximum throughout the entire value stream. So now let's talk about how to set up the items. So I already have the item master open. I see from back here. I'm going to close out a couple of these just to free up some real estate on the screen. So here's our item master. For those of you not using CloudSuite Industrial, the item master is the backbone of the manufacturing side of the software. Like the chart of accounts is the backbone to the finance, the item master is the backbone to the manufacturing or operational side. It's where you define your part numbers, where you define parameters for those part numbers, and so forth. Now, I'm not going to walk through every field in here. I'm going to just take this from perspective of how to maximize it for planning and scheduling. Let me come to this KS001 blue and show you this part. So this is a product we made at my former company, and it's essentially a Swiss Army knife for keys. I don't know if anybody has one or seen these in the store, but it's really handy. Your keys aren't jiggling around in your pocket like a Swiss Army knife. And if I come to the engineering board, this is the process for making that part. So this is the top level assembly where we put everything together. And the dark blue are the operations. The light blue are the bill of materials, or the materials needed in each operation. And you can see through the different levels. So here we have the top level assembly. Here's one of the components that we're laser etching it. And here we're anodizing it. And here we're stamping that original blank. And then all the way down here is the die, where we're maintaining the die that's going to make the stamping, which is going to go out and be anodized a variety of different colors. And then we're going to laser etch them and then put them together in the end with the screws and the washers and so forth. It's a fairly simple part, but it's a good example of showing a multi-level bill of material structure. So this KS001 blank is that stamped blank. And this is the part that we're going to talk about first. It's a component of an assembly. So you'll see here, it's the low level 3 code here. I'm going to walk through a couple of the fields here. First, I'm going to start on the planning tab. So because this is a stamped part, a manufactured part, I don't have any dock to stock or expedited lead time or anything like that. I'm using my actual manufacturing lead times for that. Here I have an order minimum, order multiple, order maximum, and days supply. These 4 fields here are key. So my order minimum, the minimum I want to set up a die and make on this particular part is 5,000 units. Now let's pretend for a second that I put 5,000 of these in a box. So I then want to run them in multiples of 5,000. So I'm targeting running them in full box quantities. This being a stamped part, I have a maximum of 100,000. When I make 100,000 hits on this tool, I need to pull it and sharpen it or do some kind of preventive maintenance on the die. So I should not produce more than 100,000 in a single setup. Then I'm also using days supply, meaning I'm going to take all my demands, because this particular part, I'm going to change here. I can make it in blue. I can make it in green, purple, red, black, so they come in a variety of different colors, but they all use the same stamped component. So I want to take all of those demands. I want to take all of those demands for all the different colors and consolidate them into 10-day buckets. So I want to run 10 days worth of parts at a time, as long as I don't exceed 100,000 units. And that's how I'm going to manufacture this part. Now let me shift gears for a second to a purchase part. So this was a manufactured part that I'm going to make against a job. Let me come down here, and this is the aluminum that I'm using to stamp that part. Now this is a purchase part, and I'm going to look at my planning tab here, and you'll notice that I've established a lead time, a standard lead time of 9 days to get this material. Then I also have a dock to stock in there. Dock to stock, for those existing customers, do not leave this at 0. Okay, dock to stock is your buffer, what the due date on your purchase order should be versus when you actually need it in production. And if you leave it at 0, you are operating in, let's say, a Toyota in mode where the material is arriving the same day that you're consuming it. Most companies, that's a little bit too lean. So you put a buffer in there. Now my buffer is 1 day. So if I need the material on Friday, the due date on the PO is Thursday. Maybe you need 3 days. Maybe you need to do an incoming inspection or some type of additional testing on it that takes you 3 or 4 days to do. Update the item master to reflect that. And you can set that at the item level on what your buffer should be. Now on the additional planning tab, I'm buying 1,000-pound coils roughly. So I can't buy half a coil, so I'm buying full 1,000-pound in multiples of 1,000 pounds. I have no order maximum, but I'm doing the same consolidation because I use this material across many different items. I want to consolidate all of my orders into a single purchase order, a single buy for this MA010001. Now, for the sake of, we're only talking about APS here, we have additional fields in terms of lot tracking and backflushing and so forth. But let's switch back to that top item here, the stamped part. And let's switch gears now, and let's look at the operations. How do we make this part? So here are our two operations. That's stamp and vibratory to burn is how we're going to manufacture this part. So in here, I have defined my 60-ton work center, the same one that we looked at in the resources, my 60-ton work center. And I'm producing them at 2,200 pieces per hour with one operator. So my pieces per machine and pieces per labor hour are the same. I want to allow 1 hour for the parts to move from operation to operation. Maybe if they're moving across the street or across town, maybe it's a shift or a day or something like that to move the parts between operations. Now, I've allocated 1 hour of setup time. Now let's come to the resources tab. So here's where some fun stuff is. So my resources. I've defined 3 resources for here. I've defined a labor resource. I need 1 member of my stamping labor pool, my stamp LRG. It's just the way I named them. You don't have to name them this way, but when you see LRG in my system, that stands for labor resource group versus machine resource group, the MRG. So I need 1 operator. I need 1 machine, but I've also added a die in there. So I have another constraint. Anything that I define here in the resources is what I'm going to constrain this process on. So the system is going to ensure availability of these resources in order to manufacture this part. Now you say, Greg, why did you add the die as a resource? Why do I need that? Well, if I don't add the die, the system may, I'm not saying it would, but it may say, hey, you got an order for 200,000 of these. Why don't you put it in machine number 1 and machine number 2 at the same time? Well, I only have 1 die, so I can't run it at the same time in 2 different presses because there's only 1 die. So this is how I established a bookmark in my system, or a constraint in my system, to only allow this particular part to be manufactured at 1 machine at a time because I only have 1 die. Now, maybe you have multiple dies, and you can do that, and it's a different way to set that up, but it's totally possible if you have multiple dies to configure it that way. But in my system right now, it's set up for just 1. Now, I have down here some setup rules applied. So I'm saying that I'm going to establish a setup rule based on a basis. You can say always apply setup time, which means no matter what, if you're producing this part, assign setup time. But I've put a rule in here that says only apply setup time if the part number is changing. So if I'm going from job X to job Y, and it's the same part number, only job X is going to get the setup time allocated. Job Y is going to say, hey, you're going to keep the setup and just change paperwork and keep going. Now, in some industries, it's not a big deal. But in other industries where your setup, maybe you're running with a Swiss mill or something like that it takes 4 or 5 days to set up your machine, properly identifying your setup time is critical. It's the difference between you having an accurate and a grossly inaccurate production schedule if you're not assigning out your setup time correctly. So again, some industries this isn't a big deal, but in others it's a very, very big deal. And I'm saying apply setup time only when the part number is changing, and I'm going to use fixed time, which is whatever I assigned back here. I'm going to say use the 1 hour. However, I can have that fixed time be part of a matrix, which we're going to talk about in a moment, where your setup time is a variable based on what you're going from and what you're going to. I'm going to change operations here on us. I'm going to change to operation 20, the vibratory deburring. So the process for this part is we stamp it, and then we put it in a vibratory deburring bowl. So when I click on this operation, operation 20, we'll see that I don't have a labor resource. The only thing I'm really constraining here in vibratory deburring is vibratory bowls themselves. Now this part is you can fit 2,000 of them in the vibratory deburring bowls in my example here. And so I have the same thing where I'm only applying setup time when the part number is changing. That's still the same. And it takes me 2 hours, or I can do 2,000 pieces per hour on my deburring process. I'm also established an offset, which means that I can start operation 20 2 hours after operation 10 begins. So that way the operations aren't running 100 like a set of stairs. They're not running one right after the other. They're actually running at the same time. So if you have, let's say, like an assembly line process where you're a work cell where it's a single piece flow, you want to use this, because if you don't have the offset checked and don't put a value in there, in that work cell, it says you have to finish all the parts in the first station before you start them in the second station. Well, in that work cell environment, maybe you're using an offset and your offset is, 30 seconds or 1 minute or whatever the case may be of however long it takes for the parts to be processed in each station in that work cell. In this example, I'm saying 2 hours after I start stamping, I can start deburring. And I'm going to come back to the resources tab, and I'm doing one other thing here with this too. I can fit 2,000 pieces in a bowl, in a vibratory bowl. So I'm saying I'm splitting it. I'm using what's called a split rule, that I'm going to allow this operation to run in multiple resources at the same time, and I'm going to do it in 2,000 piece buckets. So that when I'm producing it, I may produce 10,000 pieces or move 10,000 pieces over to deburring, and it says, all right, split them up across all 5 bowls, and you're going to run 2,000 in each bowl, in vibratory bowl, and you're done in an hour. That's a big difference on the system reflecting how quickly you can make those parts, as opposed to not using a split rule and saying, well, it's going to take 5 hours to 5 clock hours to deburr all these parts, when in reality, you're done in 1 clock hour. Again, this is a pretty simple example, but if, let's say it was 50 hours, it's a big difference. I do want to show you one thing in the bill of materials here. When we come to the bill of materials, I switch back to operation 10. So here's that MA010001, that coil of aluminum that I showed you, and we're using 0.18 pounds per unit. We are back flushing it from the floor location. If you're using coils or things like that, you need to maintain a better track of inventory, back flushing is a much better approach than issuing the whole coil if you're only going to run a half of it. So then you have to issue it, it disappears from inventory, then you withdraw it to get it back. Problem is, if you get an order in there while it's on the machine, kind of clouds the visibility of it. And then lastly, here's the die. So I have the die set up as a resource and a bill of material item. And the resource is to make sure that it's only in one place at a time. But it's also in the bill of material because I'm tracking die life. So here I'm doing 1 per unit, and I'm not tracking how many dies I have. I'm tracking what the life is remaining on that die. And I'm also back flushing that. So for every part that I produce, I reduce my die life by 1 at the same time. So I come back to the item master here, and I come to this item, the KS01 blank die. So here's the die, and I've exceeded my die life. You see my quantity on hand is negative 11,235. So the tool room supervisor is in trouble right now because he let us run this tool beyond its life. But anyways, this is how much I have remaining, how much life I have remaining on that tool. So let's look at how all this kind of comes together. We talked about how to define our resources, how to define our items, our routings, our bills of material. It ultimately all culminates in what I'll call the material planner workbench. This is your to-do list, or the system's recommendation on what you need to take action on and in what quantities. Now, in your production environments, you'll never do what I'm going to do. I'm going to go out like 6 weeks or something like that just to make sure I get all my demands in there. When you run your workbench, you go out, a day or two, a couple of days. I'm going to run it just for one planner code, like Key Smart items. I'm going to go ahead and process this. And it says I have 199 things that I need action on, that I need to take action on. Now, I ran this for purchased, manufactured, and transfer items, so I left this wide open. If you're only in purchasing, you would only care about the stuff you have to buy. Or if you're only in production, you'd only care about the stuff you have to make. I ran it wide open. And let's go ahead and look at that workbench. So my purchase orders, I'm going to change this from what I need to buy today to just all orders and see what all is out there. Now, notice here, we're seeing 2 items configured differently in what it would look like in the workbench. Remember, we looked at this coil of aluminum and we had a day's supply set. We were consolidating all our demands in 10-day buckets. Well, here's what it looks like. Saying that you need to buy 41,000 pounds for this particular item, if I click on it and come up to the planning detail, it'll show me exactly what's driving that 41,000 piece buy. And if look at this last column here on the left, here are all the different items. So KSO01 blank, PCR, KSO01 blank, PCR, and so forth. There's all sorts of different items. And if I scroll this even further to the right, it's telling me the parent item. So I have all these different customer orders that are culminating in that 41,000 pound buy. Versus this one underneath it, this is what it looks like when you don't have consolidation turned on. And each order is showing up as a line on your workbench. So you'll see 7820, 785, 785, 711, 711, 711. And you see all these individual orders that are driving it. So if you have to buy individually, you can do this. If you don't, do not do it. Turn the consolidation on so that all of these things would have been, this would have been one line, all these 7/8 would have been one, well, depends on how big the consolidation was. Let's say if I was doing 10-day consolidations, all these would probably be one day or one line on the workbench. So there's a lot of stuff on here that probably doesn't need to be. So, and then let's look at the jobs. So I'm going to change this from purchase orders to jobs. And here are all the jobs we have to create. Now remember that KSO01 blank part that had the 100,000 piece order maximum on there? Well, here we see it reflected. So I see a max quantity that I can produce at 100. These are all due on 6/28/6/28. So it's saying you need to run 200,000 on that day. My die maintenance time, I think, is only an hour or something like that, which is why it's allowing me to run it twice in the same day, because the system thinks that I can run it, pull it, service the tool, and get it back in the same day. So you can see how that is, that KSO01 blank, that order maximum is being respected. So here's 725 is we're making 210,000. So there's 2 PMs on the tool plus an additional 10,000 piece. So for those non-users, if I wanted, let me change back to the purchase orders. For those non-users, if I wanted to execute the plan on here, execute the recommendation, all I do is check this box here. So I'm going to buy one of these Buckhorn packaging ones. I would check this box. I can override the quantities, dates, any column that's in white. I can override the system's recommendation, which is basically date, quantity, and vendor, and then just hit the generate orders. And I just created a purchase order to Buckhorn Packaging to buy 20 of these plastic totes. So it's that simple. Essentially concludes our fine tuning and how to tune the engine. We can talk a lot more in either offline or in additional sessions on how to interpret some of the results in there. You have plenty of opportunity to look at data here. You can look at load profiles, which is what my capacity is for those particular machines, what the resource plan is, what the exact schedule. You can see your capacities or your load graphically. That would be the Gantt chart. I will pop the resource utilization here. This is one of my favorites. If I want to see what the utilization is for these particular resources, let's say I'm going to go out 3 weeks. And I'm going to say, show me everything that's over 80% capacity or 80% load. And I'll hit the filter here. And here are all of my resources that are over 80%. Now I have mine color-coded. It's just a conditional format in the form where they're color-coded or jump out at me. Maybe I want to say, show all the resources. And here's everything, all my resources. So this is a very useful form for saying, where am I really busy? And also really, where am I really slow? Why do I have this 2 people in my 250-ton or 2,500-ton labor group? I don't have any work for them. So train them up, get them transferred into some other area that is currently busy. Then I can look at my bottlenecks, resource and group bottlenecks, and lastly, the exception report. If for those existing customers out here that are using APS, you know all well about the exceptions report. It's the first thing you should do when you come in the morning. It's what should have happened yesterday that didn't. I see I have a question about showing the consolidation setting on the items form. Again, certainly. Be happy to. On the items form, it is on the additional planning tab. It's this field right here. Let me change the one that has it set. This right here, the day supply field. So I'm telling the system, take all my demands in 10-day buckets and consolidate them together. For this to work, make sure on your planning parameters form on your planning parameters form on the APS tab. Make sure you have this. If it's set to none, take it off, turn it off a none, and put it on days supply. It doesn't mean even the items that are set to 0 will not consolidate. But if you have this set to none, it won't even try to consolidate them. So on your planning parameters form, you can set them both manufactured and purchased items to days supply, and then that turns on this field. It makes the system consider the value in that field. I haven't been monitoring the Q&A. Are there a lot of questions out there that need...
Greg, we're caught up with the questions that have been submitted. The one question that came in when you talked about the firm schedule, and in your environment you used 48 hours kind of as a rule for that. Can that be adjusted? For example, is that a set amount, or is that something that just worked best for you in your environment?
Oh, no, that's not a set amount. Every company, it's going to be slightly different. And in all honesty, how you control that's a business decision or a procedure decision. And basically all it means is how far out you take this date when you generate your workbench. Mm-hmm. And there's no software setting to turn that on or off. It's just the plan. It's a policy or a rule that you'll have that says, production scheduler, you shouldn't be creating jobs 3 weeks or 5 weeks out, because you're actually adding work for yourself if you do that. If you are operating in an environment that is pretty volatile, your quantities and dates are pretty volatile, mm-hmm. You're actually adding work for yourself.
Exactly. Yeah. So for some environments, for the folks on the webinar here, it might be set in a matter of days, like Greg was set for 2 days or 48 hours. Others might be weeks and so forth. And this is also something that would be good to even test out in a conference room pilot as well too, as you're rolling this out. What happens if you make adjustments? What if you make it down to 1 or 2 days versus 5 days or even longer, and see what makes the most sense for you?
Yeah. The key takeaway is you do not have to create a job to consume the capacity, because the system, the planning system will consume capacity based on your orders, your forecasts, your safety stock projections. Those are actually consuming capacity and driving the plan. You don't have to create a job for that to happen.
Correct. Yeah.
Some systems you have to. Ours,
yeah, exactly right. Yeah. And then there was also one other question that I published the answer to everyone, but just to kind of reaffirm it. So the question was, is APS a separate module with an additional cost? So for those folks that are running CloudSuite Industrial CSI version 10 in the multi-tenant cloud, what Greg showed today is the finite, or what we commonly call the full version of APS. For version 10 in the cloud, the finite APS is included. For on-premise, the infinite mode is included, and the finite was sold separately for on-premise versions of CSI and SyteLine. So just wanted to confirm, repeat that question and confirm the answer for everyone.
Are there any other questions?
One just came in actually, Greg, and you touched on it. Where would you put dock to stock time? And I think you touched on that on the item master there, but maybe if you wouldn't mind just kind of reviewing that quickly here.
Sure. Let me come back to it. Dock to stock is on the planning tab of the item master, and it's primarily used for your inbound materials, your buffer for when you want the material to arrive versus when you're going to consume it. So, and it can vary from item to item. My recommendation is don't set it at 0, because the due date on your PO is going to be the need date in production. Unless you guys are really good at it, but we always used to say we're one flat tire away from shutting an automotive line down, and that's a dangerous world to be in. So you put a little bit of a buffer in there. And again, if you have to do some, significant inspection or quality testing or anything like that at the inbound side, maybe you need to leave yourself even a little bit more of a buffer.
One question came up, Greg, the APS home screen that you used. The question was, where is that? If you just want to explain quickly the home page. Sure. and how you put that together.
Absolutely. Okay, so this is just a Mingle homepage. And this page, when I create the, let's see, how you create these, each one of these white boxes are referred to as a widget. So I'm going to go ahead and I'm going to edit this page. And each one of these windows are referred to as a widget. And I can add a widget here, and there's a whole host of different types of widgets that you can use. The one that I've used is what's referred to as a menu widget. So if I add a menu widget here, and I'm going to go ahead and close this out. So I've just added the menu widget. And I'll close this out, and you'll see now I have this new white box down here. Now I can move it around if I want to. Let's say I'm going to move it up here to this first spot, and everything else will shift around. I'm going to go ahead and save, and now I have this blank widget. Now, as you're in CloudSuite Industrial and you're going to forms that you like, let's say I'm going to use resource utilization. Let's say current materials isn't currently one. So I'm going to go to the current materials. When I come up here to this bookmark, this little ribbon up here, and I can say I want to bookmark this page. And it says it's going to bookmark the current materials. Now I have a lot of bookmarks in here. Now when I come back to my home page, and I hit these three little ellipses, and here's the key part, add a link from a bookmark. And I'm going to drop this, it'll be at the bottom of the list that I just created. Here's current materials. And I'm going to keep the name the same. I can pick a pretty icon for it. Let's say I'm going to pick the pencil. And now I've just added that form to the widget, to the menu widget. Now when I click on it, it will open up the current materials form. So that's how you create the home pages here with all the links on it. It's very, very easy. No IT experience or programming necessary for this. Power users can do this. I can change this menu to, I can just come here and unlock this and I'll call it Greg. And I can just keep going. Now, you'll see some of these are folders. That's just add folder. So if you have a bunch of things in here that you want to do, like how these are all grouped together, and then I can click in there, and same thing. I can just come to these ellipses and add a link from a bookmark, and I'll pick one of these at random here. Let's say service management. These are just happen to be all the bookmarks I already have, and I click on that, and it'll open up the service management form. So hopefully that answers the question. You can have up to 20 home pages, so you'll see each one of these. The one that I'm using is the finite APS one. I also have, a CSI overview and so forth. So, and there's different. I have different ones for different events. Let's say. It's really, really easy to do these. You can change the color, right-click on it. You can edit them, delete them, change the color if you want. Any other questions?
There have been a few that I'm trying to keep caught up on here that have been submitted. I know we're a few minutes over here, but a lot of questions have come in here at the very end.
Okay. Well, I see a question on the Armingo homepage. Pages in the cloud version link? No. I believe they're version 9 and version 10.
Yeah, specifically version 9.01 and beyond, yes.
Okay. I see a question. Anything that I've shown here is not available in 9.02 or 90102. No, everything that I've shown here was available in 901.
And actually, there have been a number of questions from different folks about the enhancements that have come out. So I've replied to a number of them so far, and a few more have just recently come in. So obviously today we focus more on the advanced planning and scheduling, some of the setup and some of the impact that it has. But obviously there are enhancements both in this area as well as throughout the entire application, enhancements that have come out in version 9.0, 9.01, version 10, and so forth. Sure. So feel free to reach out to your Infor representative to get more information specifically on those enhancements. And that information can also be made available through Infor support as well, too. Incremental enhancements on those releases are also available there, too.
I see there's a question from when's it best to use APS or MRP. The big differentiator between APS and MRP is the considering capacity in your requirements planning. So if you need to consider your machine's capacity or your labor capacity, you're in the APS world. MRP is just going to tell you to bring in material, and it doesn't care about your inventory at all or your capacity at all. It's going to drive up your inventory. It's going to say you have an order for 1 million. It's due next week. Bring the material in, even though production is saying I can't run that for 6 weeks. MRP is still going to tell you to bring the material in. So that's the big drivers, is if you want to bring resource capacity into play, then that is APS world.
It's even something, Greg, where even over time, you can actually utilize APS, but only focus on the material aspect of it, and possibly over time grow into incorporating your capacity as well too, or even maybe to certain bottlenecks, for example, from a scheduling standpoint, and then expand it to the rest of the production resources.
Yeah, for sure. That's why we allow you to determine if you want a resource to be finitely or infinitely planned at the individual resource level. So again, it's not a blanket statement. There are completely legitimate reasons in the same building why you would want to finitely plan versus infinitely plan different resources in the same building based on the nature of their process. That some just don't lend itself well to. I'll give you a perfect example: end of line inspection and testing. That may be a resource in an operation, but maybe you don't want to constrain your manufacturing process based on that. That's a totally legitimate infinite resource. You don't have to be 100% infinite or 100% finite. You can ease your way into it, particularly if you have capital intensive assets that are only available certain amounts of time. Those are ones that maybe want to consider starting with and starting finitely planning first there. Again, every organization is going to be somewhat different. I can make recommendations on based on what's described, but again, ultimately, your organization, based on the nature of your business and the products you're providing and how you're manufacturing them, are going to drive that.
What are some of the key differences? There's a number, but the key differences between finite and infinite APS.
Okay, so let's use the pyramid of champagne glasses as an example, and think of each glass as the capacity of a resource. Well, if you're in finite mode, when the glass is full, it starts spilling over into the next glass. When you're in infinite mode, the glass is bottomless. So you're going to continue to pour champagne into that top glass, and it never gets full. And that's really the easiest way, I think, to describe the difference between finite and infinite.
We've got a rash of questions, just trying to keep current with them. Okay.
No, it's all right. I think I saw something about outside processing.
I actually just did a reply to that. Yeah, the question was, how does APS help with outside processing?
Yeah, so outside processing is 100% an infinite resource, first of all. So you have to define your outside processes as resources. It's 100% of the time an infinite resource. You never want to try to capacity plan your outside processes. That's their job. So set up as an infinite resource, and then you're using fixed lead time in the operation that you've defined. So APS handles it just fine. If you're sending something out for painting or plating or heat treating or something like that, you're defining a fixed period of time. Let's say it's 5 days to heat treat something. You put a fixed schedule hours in there for that operation, and then it's routed out, and it's 100% considered in the plan.
And then here's a question that obviously will take longer than we have the time to answer it here. But how would you say a company go about starting to transition from being all infinite, 100% infinite planning, or even just using MRP, into start to using some of the finite planning and scheduling capabilities that APS provides? High level, what do you think some of those key points might be?
That's a great transition. Yeah, Mike, that's a great question. So I've done it in probably 8 or 9 plants in North America of making that transition. And the what you do is you start with your, maybe not your busiest piece of equipment, but something that's got a fair amount of load in it, but maybe not the one that everybody's most concerned about. But you start with maybe that first tier down, and you separate your items into what we call A, Bs, and Cs. And your A's are your high impact part numbers that happen to run through that particular piece of equipment or group of machines. And you separate your A, B's, and C's. Your A's are your high impact, the ones you're running most often, and your high value, high volume type products. And you have maybe 25 or 30 of them. And then from there you have B's, which are the next group in the list, and there's 25 or 30 of those. And then the C's are everything else. Now here's how you do it. Your A's are the ones that you go out and you make sure that the routings are right. You get engineering out there or production control or something out there, and they're out there and they're verifying that everything is correct on the routings and bills of material. Now, while they're doing that, you also throw in something, you put a Kaizen event on it, make it worth your while. Try to get 5% out of that particular part in that operation, so you have everybody out there auditing the process for those 20 or so part numbers and get a little savings out of it. Then the B's, you have maybe one person go out there and verify them and audit them. And the C's, you just deal with them when they run. You run once a year or something like that. And you have a sheet that the operator fills out that says, oh, this routing is right, this routing is wrong, change this to that, or whatever the case may be. It's usually rates or crew sizes are the big things. Once you cycle through your A's and your B's, you basically have the foundation for doing finite planning. The finite planning stumbles typically because of bad routings, bad bills of material, or inconsistent demand, like you're adding orders that aren't real, things like that. Those are the areas that finite tends to stumble on. So you just have to start there. Start with your high impact. Maybe not your absolute busiest bottleneck machine. Don't start it there, but start at something that does have some volume in it and has some capacity, and start there and break down your items that run through there and focus on your high impact ones. And while you're focusing on them, see if you can squeeze out 3, 4, 5, 10% process improvement from them at the same time, and fund the entire project from your cost reductions from that.
And again, a great question, one that probably warrants a more detailed conversation and reviewing current operations, and obviously, Greg, that this is almost like a different philosophy towards planning and scheduling. So other groups, other departments, purchasing, inventory, even sales, quality, customer service, and so forth, need to be part of those conversations as well too.
Sure.
Yep.
Sure.
So I think we are all caught up with the questions that were submitted. Greg, was there anything else you had here before we wrap up?
No, that concludes it. I thank everyone for attending today. And again, I was a user of this application for probably 17, 18 years in industry, and it was a game changer for us, and it was a differentiator for us between us and our competition. The key part is we didn't really talk about it that much today, but it gets ETP. That the ability to provide a commitment date to a customer, and being able to keep that commitment date to a customer. It's key for good customer satisfaction. But thank you again for everyone, and